Bright Tuty. Every student matters.
Hello everyone. Now let's continue with what we had already learned so far. See, we had learned so many things regarding matter in the previous lesson. We will be carrying forward the information and our knowledge to the next chapter. Now, you see, whatever we see around us, they are termed as matter, whether it is in the solid state, liquid state, or in the gaseous state. And we know why they are termed as matter. Because they occupy space, they have got volume, and they have got a mass of its own. Now, when we see so many matters around us, one question always arises in our mind, that whether they are pure or impure. To a general person, a person who do not have much of scientific background, or a layman, for him, the things that he sees around him, he tries to identify it either in the form of a pure substance or as an impure substance. But we, in science or in chemistry, we do not try to identify matter only on the basis of purity in terms of pure substance or impure. Because in terms of science, there is nothing called impurity. So, a matter can be either pure or a mixture. So, let us carry forward all these things in the coming chapter. So, today we are going to do, is matter around us pure? Now, the question is, when we talk about
mixtures are constituted by more than one kind of pure form of matter known as substance. So what are mixtures? They are actually made up of more than one kind of pure substances, pure form of matter, and we term them as substance. So if I have to classify that what is matter classified into, then matter are classified into pure substances and mixtures. So matter is classified into pure substances and into mixtures. Now again, what are pure substances? Then pure substances can be element and compounds. Whereas when it comes to mixtures, then mixtures can be solution, suspension, whereas it can also be colloids. Now let us do an activity to study about heterogeneous mixture. So the objective is to study about heterogeneous mixture. The materials that are required to carry out the activity are: we require 4 beakers, 4 glass stirrers, powdered copper sulfate, alkaline, mixture of sand and common salt. Method: divide the class into 4 groups A, B, C and D. Provide a beaker containing 100 cc of water, 2 gram of powdered copper sulfate and a glass stirrer to the group A. Provide a beaker containing 100 cc of water, 5 gram of powdered copper sulfate and a glass stirrer to the group B. Provide a beaker containing 100 cc of water, 2 gram of alkaline and a glass stirrer to the group C. And provide a beaker containing 100 cc of water, 2 gram of a mixture of sand and common salt and a glass stirrer to the group D. Ask each group to mix the contents thoroughly and then bring them to your teacher's table. You would notice that in case of group A and B, the mixture of copper sulfate and water has a uniform composition, but the color of the solution is more dark in case of group B than in group A. This suggests that a mixture can have variable composition. In case of group C, most of the alkaline settles at the base of the beaker. The water in the beaker has a slight milky color. Whereas in case of group D, the scent settles at the base of the beaker but common salt dissolves. This suggests that the mixture formed in case of C and D are heterogeneous in nature, that is, they do not have the same composition throughout. Now this example shows you the different types of mixture. Now again we know that heterogeneous are of various types. Now what are the different types of heterogeneous mixture can be explained with the second activity that we are going to conduct. Let us do an activity to study about homogeneous mixture. So the objective of the activity is to study about homogeneous mixture. Materials required: we require 6 beakers, 6 glass stirrers, 6 funnels, filter papers, 6 torches, water, common salt, powdered copper sulfate, powder chalk, milk, blue-black ink, wheat flour, and a dropper. The method to carry out the activity: divide the class into 6 groups A, B, C, D, E, and F. Give each group 2 beakers, a glass stirrer, a funnel, a filter paper, a torch, and 50 cc of water. Provide 2 gram of common salt and 2 gram of powdered copper sulfate to groups A and B respectively. Provide 2 gram of wheat flour and 2 gram of powdered chalk to groups C and D respectively. Whereas, provide few drops of milk and blue-black ink to the groups E and F respectively. Tell all the groups to prepare the mixture in water by stirring thoroughly with glass stirrer. Tell each group to make the following observations. Are the particles of mixture visible to naked eye? Do the particles of mixture tend to settle down after a few minutes? Does the path of light become visible in the mixture when the beam of light is directed on the mixture? Is there any residue left on filter paper when the mixture are filtered? Observation. First, in case of groups A and B, neither the particles of the mixture are visible nor do they settle down after a few minutes. The path of light is not visible through the mixtures and no residue is left on the filter paper. On filtration, such a mixture is homogeneous and is called solution. The second observation is, in case of group C and D, the particles of the mixture are visible and they tend to settle down after a few minutes. The path of light is visible through the mixtures and a residue is left on filter paper on filtration. Such a mixture is called suspension. Whereas the third observation is, in case of groups E and F, the particles of the mixture are not visible and they do not settle down after a few minutes. The path of light is visible through the mixtures and no residue is left on filter paper on filtration. Such a mixture is called colloidal solution or colloid.